We've previously learned how to add, subtract, and multiply polynomials, but in order to divide polynomials, one polynomial by another, there's a couple of different methods that you can use. You can either do long division, such as we've done previously with just numbers, way back when we were in elementary school, or we can use what's called synthetic division, which we've actually studied a little bit under the name synthetic substitution, only now we're looking for a different style of answer. So if we're going to do that, we can do either method. So let's start with long division first, and then we can decide which method we like better once we performed both of them. So long division says take what's on the top of your fraction, and we're going to go ahead and divide 2x to the fourth plus 3x to the third plus, now you'll notice there's no x squared term in here. We need to have all of our terms represented. So before I go any further, I need to put in a 0x squared. Then I can continue with plus 5x minus 1. Again, make sure all of those placeholders, all those terms are represented. On the outside, we're going to divide by our denominators, so x plus 1. So let's go ahead and divide that in. Now the key to this is we want to eliminate the leading term in each step. So if I want to get rid of 2x to the fourth, I need to multiply up here by something in order to turn x into 2x to the fourth. I want to turn this front term into exactly what I already have so that when I go to subtract those two parts, I can eliminate that and essentially get 0 down here. Well, what could I multiply times x to give me 2x to the fourth? Well, I'll definitely need a 2, because 2 times 1 will give me a 2 here. And I also need x to the third. X to the third times x is x to the fourth. Don't forget that this 2x cubed, though, is being multiplied by the entire divisor out here. So 2x to the third is also times 1, which is what we're going to put right here. And you'll notice we get like terms. I can now subtract. If you'd like to, you can also distribute this in. So I can say plus the minus and minus. Some people like to do that. 2x to the fourth minus 2x to the fourth disappears. Essentially, we get 0, or we just don't get any term there in the front. We also get 3x to the third minus 2x to the third, which is just x to the third. We'll then bring down our next step, 0x squared, and we'll do the process over again. So this time we want to turn x into x to the third, so I'm going to use an x squared. X squared times x is x to the third. X squared times 1 is 1x squared. Don't forget that we're going to subtract. So x to the third minus x to the third disappears. 0 minus 1 is negative x squared. And bring down your next step. Do it again. X times negative x will be a negative x squared. X times 1, or negative 1, makes for negative x. Don't forget to subtract. Again, this is a great time to distribute that negative, so we can say plus, 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 and now it's much easier to go ahead and subtract. Negative x squared plus x squared is gone. 5 plus 1 makes for 6. Bring down that last number there, and let's do it one more time. We're going to get a plus 6 here. 6 times x is 6x. 6 times 1 is just plus 6. And don't forget to subtract. 6 minus 6 is gone, and negative 1 minus 6 would be negative 7, which just means that my remainder, my final part, can be put up here as a remainder, negative 7, still being divided by x plus 1. The problem is we just can't do anything with that. So we just place it at the end of our figure, and there is our answer. Now, you'll notice that was a lot of work. That's why they call it long division. Let's look and see how much more quickly we can do some synthetic division. Again, long division has its advantages, but synthetic division is usually much, much faster. First thing you want to know about synthetic division is you're not going to divide by x plus 1. We're going to divide by the zeros of the denominator. So whatever would make x plus 1 equal to 0, which essentially is x equals negative 1, that's what's going to go up in the box. Then we grab our other coefficients. So again, 2, 3, don't forget 0x squared, 5, and negative 1. And let's go ahead and do some synthetic division. Drop down that 2, multiply by negative 1 is negative 2, and add. The nice part about synthetic is that we're adding so much, we don't have to worry about those extra negatives, all that subtraction we did with long division. So negative 1 times 1 is negative 1, drops down for negative 1, multiply again, gives you 1, add them up is 5 plus 1, multiply by negative 1, and you add them up is negative 7. And you'll notice we got all the same coefficients, 2, 1, negative 1, and 6, as well as that negative 7 over here. Now we're not just looking for the remainder this time, that extra part, that last number, as we did with synthetic substitution. Now all of these numbers have meaning. So we can rewrite and say, well, it used to be x to the 4th here. Now we've become 2x cubed, and all of our other variables also dropped. So after x cubed comes x squared. Then there was a minus 1x plus 6. And again, the number in the box is our remainder. So we're just going to write that as a fraction, still being divided by x plus 1. And that is our answer. On the next page, I just have a couple more examples for you. Go ahead and practice synthetic division with these two, and we'll practice a long division problem here in a minute as well. Pause the video now and go ahead and try them out. All right, here are your answers all worked out. Remember that whatever makes the bottom 0 is what's going to be up in the box here. So since 2 minus 2 would have been 0, that's what we're going to put up there. Same thing on the right side here where x plus 3 was in the divisor. That makes it negative 3, the number we're going to divide by. Did all the multiplying. Remember, drop that first number down. 2 times 1 was 2, added them up, multiplied again, add, multiply, and add, and you end up with a remainder of negative 5. And what used to be x cubed now became x squared, so we get 1x squared, 4x, and 2, along with a remainder of negative 5 over x minus 2. Over on the right, when we did all of our multiplying and adding, I dropped that 1 times negative 3, made negative 1, made 3 and negative 3. Now I multiplied, got 9, and you'll notice my remainder comes out as 0. What that means is x plus 3 divided perfectly into that top part, or what we say is it was a perfect factor of, much like when we're dividing normal numbers, what goes in there nicely without a remainder is what's called a factor of my number. So that just means that my final answer is just x squared minus x minus 3 without a remainder. Long division does have its advantages here and there. Synthetic division is great when you just have x to the first. But what about x squared? Now it's a little bit harder to do that synthetic division. So go ahead and try long dividing by these 3 parts, again putting that entire polynomial x squared minus 2x minus 3 out in front. Pause the video now and I'll fill in the answers for you. All right, just after our first step, let's go ahead and do part of it here. You'll notice that I filled in my 2x squared because 2x squared times x squared will give me that 2x to the 4th. Also notice, don't forget your red part over here, plus 0x squared, because that means that when I multiply all 3 terms over here by 2x squared, we're going to get all 3 parts all lining up as nice like terms. Don't forget to subtract. 3 minus negative 4 becomes a positive 7x cubed, and 0 minus the negative 6, essentially 0 plus 6, becomes a positive 6x squared before you bring down your 5x. All right, that's that first step all completed. Go ahead and try the next one. All right, we got our next step completed. Notice I had a 7x cubed, so I multiplied 7x times x squared, got my 7x cubed down there. And again, distributing it to all the parts, here's what I got, 7x cubed minus 14x squared minus 21x. Don't forget to subtract, but there's what you should end up with. Bring down that negative 1, and let's go ahead and complete that last step together. So 20x squared means that I need to add another 20 up top here. 20 times x squared is going to be 20x squared. 20 times negative 2 is minus 40x, and 20 times negative 3 is negative 60. Don't forget that we are, again, subtracting all of our terms, and we're going to end up with then 26 plus 40 is positive 66x, and negative 1 plus 60 would be a positive 59. Now notice we can't make x squared into 66x because we would need to take away an x. So that tells me that what's left is going to be my remainder. So 66x plus 59 is still being divided by x squared minus 2x minus 3, but that makes my overall answer 2x squared plus 7x plus 20 plus that remainder written there in green. Hope that helps you with long division and synthetic division. Good luck and have fun.